Welcome back to another Algebra 2 lesson. Today we are taking a look at the FG.2 notes dealing with linear functions. So this is the second set of notes that we have in Unit 2. We first started with talking about what a function is, and now we're looking at a specific type of function, linear functions. This should be very familiar content to you from Algebra 1, so let's go ahead and let's jump right in. First, we want to look at the slope-intercept form of a line. You may remember slope-intercept form as y equals mx plus b. We're going to put this in our function notation, essentially write the same thing. This is where if slope-intercept form is going to be f of x equals mx plus b. And this is where m stands for slope and b stands for the y-intercept for any coordinate pair x and f of x. And so in problem number 1, we can go ahead and use this information to help us graph. So it says, without the assistance of technology, graph the linear function, or sorry, the linear equation here. It writes it as an equation. 4x plus 5y equals negative 20. So the first thing that we want to do with this equation is go ahead and write it in slope-intercept form. So we need f of x equals mx plus b, or y equals mx plus b. So basically, we need to go to this equation, and I need to make sure that I get the y by itself. So I'm going to subtract 4x from both sides to start. So that's going to give me 5y equals negative 4x. I'm going to write the 4x first, just so it's in that slope-intercept form. And then I'm going to need to divide everything by 5. And so I can simplify this. Y equals negative 4/5 x minus 4. So this is my slope-intercept form of the line that they gave us in the equation. The second thing that we want to do is graph the y-intercept. So the y-intercept is the b value, which in this case is negative 4. So once we have it in slope-intercept form, we can go ahead and find that y-intercept. It's going to cross at negative 4 on the y-axis. Remember, the y-axis is the vertical axis. The x-axis is the horizontal axis, unless we're told otherwise. So we've graphed the y-intercept. Now we want to plot additional points using the slope. So the slope is the m part of the equation. And so the m part of the equation, once we rewrote it, was negative 4/5. And so remember, slope is the change in y's over the change in x's, or the rise over the run, you may have called it in the past. So basically what this is doing is it's going down 4 every time we go 5 units to the right. So I can go to my point here on the y-axis, count down 4, 1, 2, 3, 4, and then count 5 units over to the right. 1, 2, 3, 4, 5. And this gives me another point to graph. I can continue this pattern. So if I tried to go down 4, it would come off the graph. But what I can do is I can go up 4, do a positive 4, 1, 2, 3, 4, and now go left 5, which would be negative 5, 1, 2, 3, 4, 5, and just thinking of the slope as positive 5 over negative 4, or sorry, positive 4 over negative 5. I could do that again, go up 4 and left 5, and there I have points that carry me all the way through my graph. From here, all that I have to do is sketch a line through the graph, or through the points. So if we're drawing that line by hand, we want to make it as straight of a line as possible, but we want to make sure that it intersects each one of the points. So the final step would be to draw a straight line through the points. Now, if you graph 2 points, 2 points is really enough. We graph 4 here just to carry the pattern of slope through the graph to get a little practice there. But if you graph 2 points, technically you have enough because remember from geometry, through any 2 points, there's exactly one line. So if you get 2 points and you draw your straight line, there you have the graph of a line in slope-intercept form. So you may remember this from Algebra 1. You did plenty of this graphing technique in Algebra 1. Now, what if they don't give you the equation of the line and we have to figure out the equation of the line? Well, let's take a look at an example here. Problem number 2 says find the slope of a given line that passes through the points negative 3, negative 2, and negative 1, negative 2. Remember, slope is the same thing as average rate of change. So we just worked with average rate of change. That's the change in y's over the change in x's, or y2 minus y1 over x2 minus x1. So subtract, find the difference of the y coordinates in the numerator and the difference of the x coordinates in the denominator. So if I take a look at this example, my two y coordinates are -2 and 2. So I'm going to subtract those. My two x coordinates are -3 and -1. Now minus a -1 would be the same as adding a positive, so I can change this to plus and plus. And then I can simplify this. This would be -4 over -2. And so my slope in this case would become +2. And I'm going to go ahead and write it with an m because m represents slope for these lines. So the slope would be 2. So if I wanted to graph here, or I wanted an equation of a line and I only had 2 points, I could start by finding the slope. Now what if I know the slope and I want an equation? Let's do it in slope-intercept form. I know the slope and I know at least 1 point, maybe 2, but at least 1 point. Well, what I can do is go back to the equation y equals mx plus b, or I'm going to go ahead and write it as f of x equals mx plus b, just to practice our notation there. What we can do is substitute in what we know for this line. So this line would be, actually, I changed my mind. I'll just make it y for simplifying things right now. So y equals mx plus b. So we can put in the two things that we need for the equation of a line. If I go back to problem number 1, I had the slope and I had the y-intercept in my equation in slope-intercept form. That's why it's called slope-intercept. It contains the slope and the y-intercept. Well, I already know what the slope is, so I can go ahead and substitute that in. 4/5, and then I still have x plus b. So what I need to find is the y-intercept, the b value. It gives me a point, but this point is not the y-intercept. This point would be somewhere, if we graph this would be somewhere over here in quadrant 2. So how can we use this information to find the y-intercept? Well, what the point does give us is it does give us an x coordinate and a y coordinate that goes together. So what we can do with those is we can replace or substitute into our equation for y and for x. And if we do this, this allows us to solve for b. So I put in -5 for x and I put in 2 for y from the points that it gave me. So then 2 equals -4 plus b if I simplify. And then I can add 4 to both sides. Get that 6 equals b, or b equals 6. Now this is not my answer. Remember, the equation of the line is what we're looking for. So y equals 4/5 x plus b now is 6. And so we need to find both the slope and the y-intercept in order to put the equation into slope-intercept form. Once we find the slope in the y-intercept form, we substitute those back into the equation, and there we have a line. Now, we do have some properties about lines that you talked about in Algebra 1, and you talked about in geometry, and then we're going to revisit again real quick. So in problem 4, it says, in the respective coordinate planes below, line A is parallel to line B, and line X is perpendicular to line Y. You may remember those terminologies or symbols from geometry. It says, use the graphs to find the slope of each respective line. So in in the first graph, let's take a look at the slope of line A. What we could do is take these 2 points. So here we have a point 0, 2, and here we have a point -5, -2, and I could substitute those into the formula, do y minus y over x minus x. But we could also simplify this a little bit, and instead of just using the formula, I could count here. So this would be up 1, 2, 3, 4 over 1, 2, 3, 4, 5. So the slope for line A here, the slope for line A, actually I'll write it down under problem A. The slope for line A is 4/5. See if you can pause the video and find the slope for line B, and then what do you notice? If you found the slope for line B at 4/5, then you would be correct. So what we should notice here is that the slope for line A is the same as the slope for line B. This is going to be true for any parallel line. Parallel lines will always have the same slope. if we think about it conceptually, that kind of makes sense. The lines could never intersect to be parallel, and so they can't be getting closer or farther away from each other. They have to be staying the same distance. Well, they can only stay the same distance if they have the same slope. So the slope for both of these two has to be the same. And that's the case for every parallel line. Now let's look at perpendicular lines. See if you can pause the video and find the slope for both x and y. Hopefully you got a chance there to find the two slopes. So the slope for line x should have been 3 over 2. You go up 3 and over 2. The slope for line y should have been negative 2 over 3. So what do we notice here? Well, the slopes are not the same. They have some commonalities there. They both use the fraction including a 3 and 2, but one of them has a 3 over 2 and the other has a 2 over 3. This means they are reciprocals. Also notice that one is positive and the other is negative. So we could say that the slope of line x is the opposite reciprocal of the slope of line y. Opposite, referring to the fact that one is positive and one is negative. Reciprocal, referring to the fact that the two fractions are basically the same other than flipping the numerator and denominator. This will be true about all perpendicular lines. All perpendicular lines will always have slopes that are opposite reciprocals of one another. So now how can we take that to an example? Let's take a look at problem number 5. Problem number 5 says find the equation of a line that goes through negative 6, negative 1, and is parallel to 2x plus 3y equals 6. Well, if I want to find the equation for the line, right now we're going to do slope-intercept form, so y equals mx plus b. So I need to know the slope. Well, if it's parallel to this line, they're going to have the same slope. So if I know the slope for the line they give me, then I can find the slope for my new line. Well, unfortunately, the way the equation is written, I can't find the slope directly. However, I can rewrite this equation into slope-intercept form, and that's going to allow me to find the slope of this current line that they're giving me. So I would subtract 2x from both sides, then divide by 3, and so y would equal negative 2/3 x plus 2. I'm going to make sure that we have that in slope-intercept form. Now, once I have it in slope-intercept form, I can see that the slope is negative 2/3. So what's the slope for my new line? Negative 2/3. So I can go ahead and substitute in that slope. Now, I still don't know the y-intercept for my new line, but now this goes back to the problem like number 3. I have a point. I have an equation here with slope in it, and I have a point that gives me an x and y coordinate. So what can I do with the x and the y? I can substitute them into the equation in order to solve for b. So if I do that, I would have a negative 1 in for y, a negative 6 in for x, and then I can simplify this expression. So negative 2/3 times negative 6 should be positive 4. And then I would subtract 4 from both sides. So b would equal negative 5. So now my full equation for the line is going to have the same slope as the original line that they gave me, but it's going to have a different y-intercept because it's going to have to go through the point negative 6, negative 1. Now the same idea can carry forth if we have perpendicular lines. So it says find the equation for a line that is perpendicular to a line that passes through negative 4, 0 and 2, negative 2. So it didn't give us a full equation this time. It told us that there's some line, if we had like negative 4, 0, and this is a rough sketch, negative 4, 0, and 2, negative 2, we want a line that's going to be parallel to this, okay? Or sorry, perpendicular to this. So what we need to do is we need to find the slope of this line that they're telling us about. So the slope of this line would be, again, the change in y's over the change in x's. So I would subtract the y, so negative 2 minus 0. over a subtraction of the x's, 2 minus a negative 4. And this would give me negative 2 over 6, which is negative 1/3. So now this is the slope of the line that they gave us. This is not the slope of our new line. Remember, to be perpendicular, two lines have to have slopes that are opposite reciprocals of one another. So for my new line, the slope, instead of being negative, is going to be positive. Instead of being 1 over 3, it's going to be 3 over 1. Now, technically, this is all the information that we need. Because if I have this equation that we had before, and I have this slope, or this line, and it has slope negative 1 over 3. If I have a line anywhere that has slope 3 over 1, they're going to be perpendicular. So it could literally have any y-intercept. As long as it has the slope of 3 over 1, they're going to be perpendicular. So you can choose any y-intercept in this case. Now let's say that the new line we wanted to also pass through negative 4, 0. Well, if that was the case, we could find the specific y-intercept. So let's say we wanted it perpendicular to this line and also going through negative 4, 0. So then I could go ahead and put in my values for x and y based on that specific point, and then solve for b. So I'd get b equals 12. So the line y equals, sorry, I believe I made a mistake there. No, that's correct. Never mind. That is correct. So if I had the line y equals 3x plus 12, this line would be perpendicular to the line they gave us information about and passing through the point negative 4, 0. Based on the circumstances for this equation, you could have literally given any equation of a line with a positive or a slope of 3, and you would have had a correct answer. And so this is basically all that we are going to have for slope-intercept 4. And this should all be very familiar to you. So this is where we're going to stop for today. In part 2 of the FG.2 notes, we will go ahead and take a look at linear equations again, but this time in point slope form. Thank you guys for tuning in, and I'll see you soon.